details of a simply supported, singly reinforced rectangular beam having the following specifications. Prepare the schedule of reinforcement and estimate the quantity of steel. The given specifications are: clear span of the beam is 4000 mm, that is 4 meters. Bearing on either side is equal to 300 mm. Width of the beam is equal to 200 mm. Overall depth of the beam is equal to 400 mm. Materials used for this design of beam are concrete grade M20, steel grade Fe 4 and 5. And reinforcement bar in tension zone 4 bars of 16 mm diameter, out of which 2 bars are cranked at 45 degrees at a distance of 400 mm from the face of the support. Hanger bars 2 numbers 12 mm diameter. Stirrups 2 legged stirrups 8 mm dia at 200 mm center to center. Covers, top and bottom covers are 40 mm and side cover is also 40 mm. From the given data of a simply supported, singly reinforced rectangular beam, different types of bars are to be provided in the beam. The length of several bars such as main straight bar, main cranked bar and a hanger bar and stirrups are to be provided in the beam. First we calculate the length of main straight bar. The schedule of reinforcement, say A is the main straight bar. Length of main straight bar is equal to it is LMS. Therefore, LMS is equal to, say this is a beam and supports. Clear span is 4 meters or 4000 mm. This is the depth of beam. See, this is the main straight bar. Here we have to take clear span 4000 meters plus width of support is 300 mm on both sides. So 2 into 300 minus this end cover. This is 40 mm. End cover is 40 on either side of the beam. 2 into 40. Therefore, length of main straight bar is equal to 4520 mm. There is an additional length due to bending of straight bar into a cranked one. Let's draw the bending of a bar like this. Say this is the bending portion. Say it is bending at an angle 45 degrees to the horizontal. Cranked bar. So this is the distance D from center of this bar here to here. Sin 45 is equal to opposite, so it is D by, this is D inclined, D by D inclined. Therefore, D inclined is equal to D by sin 45. Tan 45 is equal to opposite by base. Say it is dB. dB. Therefore, dB is equal to d by tan 45 degrees. Simplifying these two, di is equal to 1.414 times d. dB is equal to 1 times d. Why? Because tan phi is equal to 1. 1 into d is equal to d. Therefore, additional length of crank bar is equal to this sloping distance minus this base distance. Additional length of crank bar is equal to 1.414 d minus d. This is equal to 0.414 times d. Here we have to calculate the d. So d is the vertical distance from center of the reinforcement here to center of the reinforcement here. Overall depth of the beam is 400. This is 400. Top and bottom end chords are 40 and 40. So 400 minus 40 minus 20 minus half of dia here and minus half of dia here. D is equal to overall depth of the beam minus 2 times the cover minus crank bar diameter is 16 mm. So half of dia on the top side and half of dia on the bottom side. Therefore D is equal to 304 mm. Therefore additional length of crank bar is equal to 0.414 into 304 mm. Length of main crank bar, say it is B. Length of main crank bar LMC. Let us assume it is LMC. Length of main crank bar is equal to length of main straight bar plus 2 into additional length of crank bar. Length of main straight bar is equal to 4520 mm plus 2 into additional length of crank bar 0.414 times D. 0.414 times D. Therefore, length of main crank bar is equal to 4771.71 mm. 4772 mm. Calculate the length of hanger bar which is provided on the top portion of the beam to support the crank bar. So it is C, hanger bar, which is also known as anchor bar. Length of hanger bar is equal to length of the main straight bar. Therefore 4520 mm. Stirrups. Draw the cross section of the beam. See, this is a stirrup. (135° bend). This is the diameter of the stirrup, which is 8 mm. The cover, top cover, bottom cover, side covers are 40 mm. So cover is from this top end to this portion. This is 40 mm. Similarly here, from this side of the beam here to this portion, length of the stirrups. So this center of the stirrup to this distance on both sides plus center of the stirrup here to here. So it is BS DS. So length of the stirrups is equal to 2 times BS plus 2 times DS plus 2 bends lengths. So these are bent at an angle of 135 degrees. For one 135 degrees bend, the length is 12 times dia. 2 bends. Therefore 2 into 12 times dia of stirrup. Calculate this BS and DS. BS is equal to overall width of the beam 200 minus 40. 2 into side cover 40 plus this half of dia of stirrup plus half of dia of stirrup. 2 into from here to here half of dia of stirrup. Dia of stirrup is 8 mm. Half of dia is 8 by 2. Therefore BS is equal to 128 mm. DS is equal to 400 is the overall depth of the beam minus 2 into 40. Top cover minus bottom cover plus half of dia into 2. DS is equal to 312 mm. Therefore, length of the stirrup is equal to 2 into BS. BS is 128 plus 2 into DS 312 plus 2 into 135 degrees bend length 12 times dia of the stirrup. Therefore, length of stirrup is equal to 1104 mm. Number of stirrups, say NST, to resist the shear, is equal to total length of the beam excluding the end covers, which is equal to length of main straight bar divided by center to center spacing of stirrups. Plus 1. Length of main straight bar is 4520. Center to center spacing of stirrups is equal to 200 mm plus 1. Number of stirrups is equal to 23.6. We can round it to 24. Length of required bars are determined. Now prepare the bar bending schedule. See, the bar bending schedule consists of a table, serial number, bar designation, shape of the bar, diameter of the bar, number of bars, length of bar, total length of bar, weight of the bar, total weight of the bar. First bar is main straight bar. The bar designation is A. Shape of the bar is straight and diameter of bar is 16 mm dia. So, diameter of bars are in the mm. Number of bars are 2. Length of the bar is 4.520 in meters. Total length of the bar is equal to number of bars into length of the bars. So 7th column is equal to 5th column into 6th column. 2 into 4.52. 9.040 meters. Weight of the bar. Calculate the weight of the bar in kg per meter. For 16 mm diameter bar, weight of the bar is 16 square divided by 162.2. This is 1.578. Now total weight of the bar is equal to total length of the bar into weight of the bar. So 7th column into 8th column. 9.04 into 1.578, which is equal to 14.265 kgs. Why? Because meter into kg per meter. Meter gets cancelled and total weight comes in the kgs. Next bar is cranked bar. Designation is B. And cranked bar diameter also 16 mm. Number of cranked bars are 2. Length of the cranked bar is 4.772 meters. Total length is equal to 2 into 4.772, 9.544 meters. Weight of the bar is 16 square by 162.2, 1.578. Total weight of the bar is equal to total length of the bar into weight of the bar, 15.060 kgs. C is the hanger bar, which is a straight bar. Diameter is 12. Number of bars are 2. Length is equal to 4.52 meters. Total length is equal to 2 into 4.52, 9.040 meters. Weight of the bar is 12 square by 162.2, 0.887. Total weight is equal to total length of the bar into weight of the bar. It is 9.04 into 0.887, 8.018 kgs. Fourth bar is stirrups. The designation is D. Stirrups like this. Diameter of the stirrups is 8 mm. Total number of the stirrups is 24. Length is equal to 1.104 meters. Total length is equal to 24 into 1.04, 26.496. Weight of the bar is equal to 8 square by 162.2, 0.394. Total weight is equal to this into this, 10.439 kgs. Now calculate the total weight of the steel required for the beam. Total quantity of steel is equal to 47.782 kg.